Hello, and this is just a video on the dot product. Oh, I've done that again. I'm really bad at doing that. So what this video is about is we've talked about already how to multiply vectors by scalars and things like that, and we've added and we've subtracted and things like that, but we really haven't talked about multiplying two vectors together. So in other words, we've multiplied a vector. So let's just say 2i minus j plus k or something like that. We've multiplied this vector by a scalar, this scalar 3 here, and that would be 6i minus 3j plus 3k. We've multiplied it by a scalar, but we haven't multiplied two vectors together yet, and that's something we need to consider, and it's a little hard to think about what that actually means. Multiplying two vectors together. It makes sense to add two vectors together. It's the sort of the net effect of two things, two forces or something like that. But multiplying them is a different case, and I'll explain this more in class. And so I'm just going to assume a few things. I'll explain it more in class. It's too hard on the video, and I'll show you. So what we've got is the dot product, and the way we write the dot product of two vectors A and B is A dot B, like that. The dot product, and we call it the dot product because we write it with a little dot there. And what the dot product is equal to, and you're going to have to take my word for this and why this is the case. Like I said, I'll prove it in class. The dot product is the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle in between the vectors A and B. Now, you just have to be careful here. This theta here is the angle that's between the two vectors when you draw them tail to tail. Okay, so if there's our vector A and there's vector B, the cosine is this angle in here, so there's theta there. Okay, so just be careful, it's between the tails. If you draw it tail to head, and put them together, that's the angle there. It's not, and I repeat, not this angle here. So don't get confused, it's not that. So I'm just going to draw that in red so that it's very clear as to see it's not that angle there. Very important, tail to head, like that. Very good. So that's our definition for dot product, and so let's just do a quick example. So an example, let's find the dot product of A is equal to, just really doesn't matter, I minus 2j plus k, and B is equal to 2i minus 3k, something like that. Don't forget your tildes, because I always do. If you got those two, then what's A dot B equal to? The dot product is the magnitude of A. Now the magnitude of A will be equal to the square root of 1 plus 4 plus 1, which is root 6, and the magnitude of B is equal to the square root of 4 plus 9, which is root 13. Oh, and I should just say, let's just I didn't say what the angle was between them or anything like that. Let's just say that's A and that's B, and we've got 29 degrees between them. Okay, so the dot product of those two will be equal to the magnitude of A times the magnitude of B times cosine of 29 degrees. And you could punch that into your calculator and find out what the dot product is. And what you'll notice is the dot product is, I don't care by the way, you punch that into your calculator, it's a number. What you get is a number, a scalar. You do not get another vector. When you multiply two vectors together using a dot product, you end up with a number, a scalar. You don't end up with another vector. So that's really important to realize. Really important. Okay. Okay, let's go on, and what I'm going to do now is just look at a few properties of the dot product. And a lot of these are what you might expect. The dot product does usually follow what the rest of algebra follows, and so it shouldn't surprise you too much. The first one is the dot product of two vectors doesn't matter which way you write it. So it doesn't matter. A dot B is equal to B dot A. It does not matter. Secondly, if you multiply the dot product of A and B by some constant here, so if the K is just some real constant, it doesn't matter which order that constant can go to either A or B. It doesn't matter. It's just like algebra. That can be K times A dot B, and it can also be, what would the alternative be? K times B, A dot that. Doesn't matter, the K can go to wherever it wants. It's just like, it's the same as if you've got 3 times x, y. That would just be equal to 3x times y, or it could be x times 3y. It doesn't matter, okay? So that's just what this is saying. It's just intuitive. It shouldn't really be that surprising. The dot product of A, any vector, and the 0 vector, can you guess what that might be? Yes, it's just equal to 0. So if you multiply something by 0, it equals 0. Makes sense. Also, if you've got brackets, if you've got a dot product with an addition in there, with our distributive laws, what would you might think this might be? Yep, it follows exactly what algebra says. It's equal to A dot B plus A dot C. These are all got tildes, by the way. I'm just being really lazy. Forgive me. Also, a really important result is this, and this is probably the most important result. If you have that A dot B is equal to 0, what this tells you is that either A is equal to 0, B is equal to 0, or, most importantly, if neither A is equal to 0 or B is equal to 0, that means that cosine of the theta must be equal to 0, which means that A and B are perpendicular. And if the cosine of theta is equal to 0, that implies that theta is equal to 90 degrees. So this is the most important result here, that A and B are perpendicular if A dot B is equal to 0. This means this generally, because usually we don't have A or B equal to 0. So that is a really important result in proofs and such. So really important one to remember. What else do we have? Another important one, if you've got the dot product of itself, so A dot A, what that is equal to is the magnitude of A squared. And I'll show this one in class, because I could show it a bit later. I'll see how I feel, but that's the magnitude. So what that means is the no, I'm not going to do it now. Too silly to do it now. And lastly, if you've got A dot B will be equal to A magnitude of A times magnitude of B. So if cosine of theta is equal to 1, that implies that theta is equal to 0. And so that means if A and B are parallel, you'll get this situation happening here. So there's a few sort of laws, a few things that you need to be sort of aware of with the dot product. And what I'll do now is show you, again I'll prove it in class, but I'll show you quite simply if A is written in IJK form. So if we write A as A1I plus A2J plus A3K. So A1, A2 and A3 are just the horizontal, vertical and orthogonal components of these. And similarly, if I've got B equal to B1I plus B2J plus B3K, if I've got two A and B like that, that means that the dot product of A and B is a much simpler way of working out. You just multiply all the pieces together. So we multiply A1 by B1, A1 times B1, plus A2 times B2, plus A3 times B3. And that's our dot product there. That's a much simpler way of figuring it out. So what we've got next is, I'll just give you an example of that. So an example here, if you've got A is equal to 2I minus 3J plus K, something like that, and B equal to I plus 9K, something like that. What's the dot product? Let's have a look. A dot B will be equal to, just have to multiply all the components. So let's multiply the I components together. 2 times 1, so that'll be 2, plus, let's multiply the j components together. Here we have negative 3, over here we have 0. There's no j component over here. What's negative 3 times 0? 0. And here, let's multiply the k components together. We've got 1k here, you've got 9k here. 1 times 9 is 9. So a dot b is equal to 11. That's how simple finding the dot product is of two vectors if they're written in I, J, K form. Very, very simple. Okay, so the last thing I want to show you is just angles between vectors, and this is another quite powerful use of the dot product. Okay, so sorry that my A and B always look the same, it just seems to be the easiest way to do it. Now we said before that A dot B is equal to the magnitude of A, magnitude of B cos theta. So if we're trying to find the angle between two vectors, we can just sort of rearrange this. So cos theta will be equal to A dot B over magnitude of A, magnitude of B. That's how we can find the angle between two vectors. Okay, so really simple. Let's just do an example. A equal to I minus J plus 2K. Just making up numbers here. And B is equal to 4I minus 5J minus K. Let's find the angle between these two vectors. So, to find the angle, we'll need the dot product and we'll need the magnitude of A and magnitude of B. So let's just do all those things. So magnitude of A will be equal to square root of 1 plus 4 coming from this. So that's equal to the square root of 6. The magnitude of B is equal to the square root of 16 plus 25 plus 1. So what's that? 26 plus 16, 32, 42. So root 42. Can that be simplified? No. And then also we've got our dot product. A dot B is equal to, what's the dot product? 1 times 4 is 4. Negative 1 times negative 5 is positive 5. And 2 times negative 1 is negative 2. So A dot B is equal to 9 minus 2, which is equal to 7. So therefore, the angle theta will be equal to, I'll just do cos theta first, just to not confuse anyone. A dot B is equal to 7 over the magnitude of A, which is root 6, times magnitude of B, which is root 42. And so I'm not going to do it on the calculator, but you can easily do it. Theta is equal to the inverse of all that rubbish from before. Just do that all on your calculator. I'm not going to bother doing that, and you'll get your angle between those two vectors. And basically that's all there is to dot product, and we'll do more of that soon. Thank you.